Hey, Mr. Can you hear me now, Mr. Nathan? Can you hear me now better?
Yeah, I can hear you.
Okay. Okay, good.
What are we doing today, Professor?
Hmm?
You said, what are we doing today?
Yeah, that's what I was about to show you before I started having problem um with my network. We'll be finishing chapter 3 today, and not today, next week, I mean to say. But I'm showing you the class assignments before the issue started. So we started all over again. So we are still in the class. I'm going back to the classroom. So an announcement I made, you can see that one that I have due today, which you can submit tomorrow. I'm talking about the classwork. See the classwork 5 due today. Homework 2 and 3 is due to by Sunday, but I may extend it. We see. And I mentioned that you can access all this by going to the models and then clicking on the classwork or the homework, whichever one you want to complete. But the classwork is a video that what you gotta watch. This video, the link right here, and I put the instructions here on what to do before once you finish doing that, you can upload. Um, so what else? What else do I want to say? Okay, I'm still grading some of your classwork. I'll be finishing probably next week, but I'm gonna grade more this weekend by weekend, mm, or during the weekend. So having explained that, I'll take you back to the workbook. Today we're working on the same thing we did last week, but this time on grouped data set. Look at the first one. We'll be starting with the weighted means. So we call them weighted mean because the each section or part of it, there's a weight that is assigned to it. So that's how the name weighted mean or where it comes from. For example, your GPA. For this class has 3 credit loads. That is the weight. So if you have A in this class, um, then A has 4 points. So that means the weight is 3 because it's 3 credit loads, and A has 4 points. So the total will be 3 times 4. Now, another example of a weighted mean, your credit score. Your credit score comes from there are different variables that make up your credit score. Your payment history, uh, how how uh, good you are with your payment. But when I say that, I mean paying on time before the due date or at the due date. Then how many credit score, how many credit cards you have. So all those things I just mentioned have score that add up to make up your credit score. So it's a good example or it's another good example of a weighted mean. So the formula for calculating the weighted mean is shown in the screen here. Can see right, it says sum of s bar, weighted mean s bar, sum of x, sum of the weight times x divided by the sum of the weight, where w is the weight and x is the data values. So let us do an example here. It says Jessica's score, her score in various courses are presented here. On English 80, which have a weight of 3 points, she scored A. That is 4 points right there. History has a weight of 3 points. He scores C, which is 2 points. Statistics have a weight of 4 points, and she scored B, which is 3 points. And then next is the biology has a weight of 2 points, and he scored D, which is 1 point. So compute Jessica's grade point average. So grade point average is another example of weighted mean because as you can see, each grade has a weight. Um, sorry, each course has a weight assigned to it. So now you want us to calculate the Jessica's GPA. So first thing is to put them in this form. Consider that A has 4 points, C has 2 points, B has 3 points, D has 1 point. So we put them those points here. Now we're ready to calculate her GPA. So you see, weight times grade. W times S means weight times grade. So you have that 3 times 4 is 12. 3 times 2 is 6. 4 times 3 is 12. 2 times 1 is 2. When you add them for totals, let me write them down so you can so that we can add them. As a matter of fact, I can even do it mentally. 12 plus this one is 12 plus 6 is 18 plus this 2, 20. Then 20 plus 12 is 32. Okay. For the credit, for the weight, 3 plus 3 is 6 plus 4, 10, 12. So that her GPA becomes weighted means x bar, which is sum of weight times x, but sum of x, sum of the weight. And we got sum of weight times x. We have it as 32 right here. So we have it 32 divided by 12, which is sum of weight. That will give us the her GP. So taking you to the calculator, we have 32 divided by 12. 2.7, approximately 2.7. 2.7 points. Her GPA is 2.7 approximately. So this is basically what the computer does when it calculates your GP. Exactly what I did, but now it did it. It will do it automatically as soon as your grade is entered. Does anybody have a question on this? Any question on this? Okay.
No questions.
No question. Okay, good. Now, let's do one that is more challenging. Look at this one here. It says the data below represent the net worth of in billions of 45 national corporations. So you can see here 10 to 20 billion. The frequency is 2, 21 billion to 31 billion. The frequency is 8. 32 billion to 42 billion is 15, and so on. It says, compute the following: the mean, the median class, and the median, the modal class and the mode, the variance, the standard deviation, and they say explain a result. Now, unlike the one that are on group data, the one we did last week, where you can just add the numbers and divide by number of items. This one you can see that they are grouped 10 to 20, 21 to 31. So that will require more work. So the good news is that we have Excel that can help us to make it faster. So the first thing to do is to put this data set in Excel, get the totals. Then we can come back here and finish the work on that. Okay. So again, they want us to calculate a lot of things there. And so let me put this on Excel. I'm gonna copy this here. And put it in Excel. Okay. Oh, excuse me. Copy this here and put Excel. It make it faster for us. Like I said, we'll be using Excel extensively in this class. I'm gonna paste it right here. Yeah, it's too large because of the so I'm gonna make it to be just 14. 14 is good enough. This is the net worth in billions. And this is the frequency F. I use F for frequency. So now we can be able to work on it. So I'm gonna the way it is here, you cannot get the midpoint. Now, I'll come back to this in a minute. Like I explained a few minutes just earlier, because these are grouped. Because they're grouped, you cannot just add them and divide by number of items to get the mean or to the variance the way we did it last week for ungroup data. To be able to get these answers here, you need to get a new table like this one, where you get the midpoint, which becomes your X. Frequency is given. You need the cumulative frequency since you are going to calculate the variance and standard deviation. So you need the cumulative frequency. Sorry, my mistake. You're going to get the median class. So that's why you need the CF. Then you need F frequency times X column, S squared column, and frequency times S squared column. We need this column because we're going to get the variance and the standard deviation. So let's go and get all this answer for all this. Create this kind of code in Excel right away. I'm taking you there. Excuse me. So you have it here. I'm going to have net worth. Okay. Which is I'm gonna again reduce it to 14. Okay. I can still go okay. Now I can bring it a little bit bigger. So I can bring this up. So it won't be taking too much space. Okay, this net worth. Okay. It has the lower end, lower side, lower interval and upper interval. So I'm gonna put the lower here and the upper. Okay. So off for 10, 10, 14. And why is doing this? Now, we need the midpoint. I'm going to type midpoint here. Okay. Then we also need the frequency. I'm just going to use F for frequency. F. For cumulative frequency, we're just going to use CF. Okay. Then F times X, I'm going to put it F times X. Okay. I have X squared. Then F times X squared. F squared. X squared. Okay. So now I'm going to highlight or make them to be reasonably not too big. Good. I have everything, midpoint. Okay. Now we're ready to work. For the lower side, we have 10, 21, 32, 10, 21, 32, 43, 54, 54, and then 65. For the upper end, we have 20, 31, 31, 42, 53, 53, okay, 64, 75, 75. Now, to get the midpoint, here is the formula for the midpoint. I'm gonna show you right here. Okay, the midpoint is make it bigger. Lower interval plus upper interval divided by 2. That's how you get midpoint. Lower interval divided plus upper interval divided by 2. Okay. Having said that, I'm gonna take you back there. I say the lower and say the upper. So to get them midpoint equal sign, put the parentheses, lower interval, click on it, plus, put upper interval, close the parentheses, then divided. The forward slash is the division symbol, right? 2. Then you can press the enter key. Again, the midpoint, then you can copy it and calculate the rest. Okay, now the frequency is given 2815, 815, okay, 7, 10, 3, 7, 10, 3. For the cumulative frequency, to get it, if you still remember, the first cumulative frequency is the same as the first frequency. And to get the rest, just add to the next number. So you can put equal sign. Remember to put equal sign in the cell before you can make any calculation in Excel. So you put parentheses 2, excuse me, 2 plus the next frequency. Then close the parenthesis, press the enter key. And then you're going to copy it down to calculate the rest of them. Click and drag down. 45. Okay. Now next will be frequency times x equals frequency. Asterisk is the multiplication symbol times x. X is the midpoint here. So for this one, we use x as the midpoint. And then again, copy it down to calculate the rest of them. Now, x squared, this x squared, we need this x squared to be able to get f times x squared. So let's get the x squared equal. You square all the x's. Remember, the midpoint is the x. Let me put it there so you can know that it is the x right here. Midpoint is the x. Okay. All right. So I'm gonna expand it a little bit. So x squared means square all the midpoints. Click, put equal sign, the parentheses, click on one of them, and then close the parenthesis and press enter key. So that means 15 times 15. Okay, I didn't square it. Sorry, mistake. Put equal sign, put parenthesis, click on 15, close the parenthesis, raise to the power, press the shift key, and put this symbol, cap. That represents raise to the power in Excel. So raise to the power 2, put 2 right there, and press the enter key. You have 2 to 5. And you can now drag it down to get this. Okay, next is the frequency times x squared. Means this frequency here times x squared. Okay, equals frequency here times x squared, which is this one right here. And press the enter key. And then, of course, drag it down. Okay, now let's get the totals. Okay, we don't need total for upper and lower. We don't need total for midpoint. We only need total for the frequency. So put equals sum. It will pop out, double click, highlight all this. Then close the parenthesis, press the enter key, you get the total for this. And then you can copy this down, calculate the rest of the totals. Now we don't need total for cumulative frequency, so remove that. We need total for this one. We don't need this x squared total, we don't need that, so remove that. So you have your table of net worth. I'm gonna make this to be measures for this side only, measure center. So I'm gonna make everything, highlight it properly, put all the lines, and then I'm gonna make this size measure and center. Okay, I'm gonna copy all of this, Control C, go to our workbook and paste it there so you can get our answer. Okay. Okay, so I'm gonna paste it right there. You can see it right there. And make it 16. Okay. And you can see our totals right here, highlighted. Now we are ready to calculate the question will ask us to find the mean, median class, modal class, and mode, variance, and standard deviation. So the first thing we need to calculate is the mean. So mean, making this 18. Mean, I'm gonna get a formula for the mean. I'm gonna open another workbook so you can get the formula for the mean. Okay, this one mean will be mean X bar. Okay, I'm gonna share this. Mean, which is your, I'll make it big. Yeah, 18. Mean is, okay. Mean, which is the X bar. X bar. Mean, it is X bar equals the sum of X over sum of F times X. Sum of F times X. Oh, excuse me, I put it outside. Sum of F times X times X over sum of F. Well, this is the now the this is the group data. So that you can see that from our what we have on the screen, sum of F times X. This is let me bring this table down. You can see that this is the F times X here. The sum is 1929. Write it down. Sum of F times X over sum of F, 1929. You can see the sum of F times S here. Okay. The sum is 1929. And F is right here. Sum of F is 45. Okay. We can go and put them there to get our mean. Okay. That 1929 divided by 45. Okay. So you can get this on the calculator. As a matter of fact, we can get all of this from, okay, let's go to a calculator. Let's just save aside for us. 1929 divided by 45. 42.9. 42, approximately 42.9. Write it down. 42.9 billion. So I'm gonna take you back there. You got 42 point, oh, excuse me, dollars. It's in dollars. 42.9 billion dollars. That's me right there. I'm gonna copy this. Okay. And paste it there. So you got to mean as 42.9 billion. And you can see the interpretation right here. The average net worth of national corporations is 42.9 billion. Now, does anybody have a question in what I just did? Any question on this? Yeah, no question. Excellent. Now, next is median class and the mean and median. In the example we did last week, to find the median, you arrange the data set in order in ascending order of magnitude and pick the median from the middle. However, this one is not as simple as that one because this one is group data. So we can only estimate what the median is. We cannot get exactly we will not get exactly the exact value for the median. We only estimate it. Okay. So let's do that. 45 is the total. So it should be at the middle. Let's say 45 divided by 2. Okay, total is 45. Total has 45. Then we have 45. 45 divided by 2. You're gonna get 2 divided by 4 is 2. 2 divided by 5, 2.9. remember one, add 0 to that here, 22.5 is the middle. That's where the median will be located. So we can figure out, we cannot get it exactly because we have to find the median class first. 22.5. At this point, you can look at the cumulative frequency. It can be on the 2, it can be on 10, but it's around here where we have 25. Because that's why you can see 22.5. You follow this to the end, you can see that this is the median class right there. 32 to 42. So our median class is 32 to 42. 32 to 42. Like I said, for this one, the median, you can only estimate it. Or I can use there's a special formula you can use, but that's to still give you the estimate because this is a group data. So now that means that the median will be the midpoint of the median class. Median equals midpoint of the median class, which is, we look at this, the median class, the midpoint, okay, is 37 billion. So the median is 37 billion. 37 billion. Now, if you use a formula, you might get a value that is a little bit different from this. Because like I said, this is a group data. We can only estimate it. Okay? We can only estimate it. So this means that the median is 37 billion. What does that median of 37 billion implies? It implies that half of the national corporations have a net worth of 37 billion or less, while the other half has a net worth of 37 billion or more. Any question on this? Any question? Okay, excellent. Now let's find the mode then, since there's no question. To find the mode, you need the modal class. Modal class is the class that contains the mode. Now, if you go up a little bit, the mode is the value with the highest frequency. This is our frequency here. The highest frequency here is 15. So that should be the mode, 32. So that the modal class is right here, 32 to 42, because it is the class that corresponds to the highest frequency of 15. So mode is 32 to 42. And modal class is 32 to 42 again. Again, this is a coincidence that median class and modal class are the same. Okay, so the midpoint of that class is the mode. And the midpoint of that class, like before, is 37 billion. So that means that the mode is 37 billion. Okay. So which means that most of the national corporation have a net worth of 37 billion. Okay. So far we have found the mean, median, and mode. We have found mean, median, and mode. Now it's time to calculate the variance and the standard deviations. So let's find the variance and the standard deviations. Again, this is a group data set. So we have a different formula. The same formula, but the frequency part is added to it or is factored in. Now, to find the variance, we need this f times s squared and then f times x and f. So our f times x squared is 92031. I have it here written for you. F times s, the total is 1929. I have it here for you. Then some of the frequencies 45. I have it here for you. So let's get the variance. I'm gonna write the numbers down and then take you to the other workbook so that we can calculate the variance. So we have sum of f times x squared is 92031. Sum of f times x is 1929. Sum of f is 45. So we can now get and calculate the variance. using the formula. So I'm going to take you there, the other workbook. So you have variance equals, I'll make this into 16. This is to even 14. Make it 14. No, 15, 16 is good enough. Variance equals, oh, excuse me, um, sum of, okay, f times x squared, f, yeah, times x squared, okay, squared minus sum of, okay, let me put this, oh, square, I think I made a mistake. Okay, minus, use this one. If I put this one, okay, I'm gonna have sum of f times x, get f times x times x squared over sum of f divided by sum of f minus 1. Okay? Like I say, all these numbers have already there for you. Let me show you to them again. Sum of f times x squared, you can see from the table. F times x squared, you can see 92031. I have it here. Sum of f times x is 1929. F times x is 1929. And sum of f is 45. You can see that f right here and the sum is 45. So you just gotta put numbers in and get the variance. Okay, so you have f times x squared. I wrote it down as 9092031. And also you can see sum of f times x squared. I got it there as, I'll put this one first. I got it there as everything is okay. Got it at 1929 squared over sum of x, sum of x, which is 45, divided by 45 minus 1. So I'm going to put the variance right there, write it down, and then I can calculate it. 92031 minus 1929 squared over 45. 45 minus 1. Okay. Now let's go and put this in the calculator and get our answer. I'm going to make this layout to be long. Orientation, make it landscape. Okay, good. So let's go to our calculator. Get this. So we got 92031 minus, okay, 1929 square over n is 45. Okay. I made a mistake, I think. Yeah, I'm gonna make a small change so you can get it. 31. Yeah, because this is gonna be then I can go now. Minus, okay, 1929. No, excuse me, 29 squared over n, which is 45, divided by 45 minus 1. 212.3 minus 212.3. That's our variance. 212.3. So 212.3. Okay, so I'm gonna copy this to get our variance. Yeah, and take it to main workbook. And make it longer. So I got 212.3. Excuse me. What was it? Right here. That's it. So normally we don't use variance for the interpretation. We use mainly standard deviation. But we need to calculate variance so that we can be able to calculate the standard deviation. The standard deviation is just the square root of variance. So I'm gonna go over the right way to a book to put it. Okay, standard deviation equals the square root of variance. Okay, how the square root of the variance, which is the square root of our variance is, we got our variance to be 212.3. So we're gonna put it right there. 212.3. That will give us the standard deviation of we get it from the calculator. Okay. Square root of 212.3. 14.6. Write this down. That pen. 14.6. Oh, something on the floor. 14.6 SD was the square root of 212.3, which is 14.6. Approximately 14.6. So I'm gonna go over there and put it. Oh, excuse me, I gotta put this in the right place. 14.6. Okay, well, Control C and then put it at the right place. Okay, here, 14.6. Now, any question on this? Any question, guys? Okay, so no question then. So now we have calculated. So the variance, the standard deviation is high. That means that that means there's a wide disparity in the net worth of these national corporations. High standard deviation means that the data value are widely, the straits high, so very far from the center, from the mean. That what it implies. So now I have shown you how to calculate the measures of central tendency for on-group data last week and for group data this week. We can now proceed to the next measure, which is called measures of position. Okay. Now, the measures of position measures, we use them to locate the relative position of a data value in a data set. For example, if suppose that you scored or your score that a value is located at the something like 80th percentile, it means that 80% of the data value fall below it and in the distribution and 80% fall above it. So we have 4 measures, actually 3, because one of them you can use the other one to estimate it. The standard score, the percentiles, decile, and quartiles. Now, the standard score tells us the number of standard deviations a given value x falls from the mean. Normally, when we want to calculate it, we use this formula: value minus mean divided by the standard deviation. Otherwise, we can write it in this form: x minus mean divided by the delta, which is the standard deviation, where z represents the standard score, x represents the delta value, delta represents the standard deviation, and mu represents the mean. So, of course, I told you at the beginning that this is how we write population mean, mu. Sample mean is x bar. Population variance is delta squared. Sample variance is s squared. And of course, for standard deviation, it's very simple right here, and so on. So, this side divide the data set into 10. This is the one we're not really focusing on it, because when the size is the same as 10th percentile, so we'll be looking at more as percentile. Now, percentile divide the data set into 100 equal parts. We're working on this one, and this one we call quartiles. We divide the data set into four groups that are separated by Q1, Q2, and Q3. Then in the mid quartile, which is basically a rough estimate of the second quartile. And we use the formula to find it: Q1 plus Q3 over 2. Now, outliers, we don't use outliers because of the fact that it can, we don't, so if you are doing, if you're working on a distribution that is not symmetric. Now, let us calculate some of this. I will be doing exploratory data analysis sometime, maybe next week. Let's start from there. Let's find the z-score first. Calculating the z-score. Z-score is the easiest to calculate. And look at this question here. It says a student scores 60 on a math test that has a mean of 54 and a standard deviation of 3. She then scored 80 on a history test with a mean of 75 and a standard deviation of 2. Suppose she also scores 65 on biology test with a mean of 75 and a standard deviation of 2. Which test did he perform better? Okay, the first thing to do is to find the standard score. That's the first thing to do. So I'm going to bring it up a little bit so you can see that. So you can see the scores in different subjects. Okay, let me see. Mass, mean for the mass is 54. I mean, average for the class. And the standard deviation is 3. And S is his score. History is 17. And then biology. Okay. So now let's find the z-score for mass. It's a S minus mean of a standard deviation. And the S is 60. So that's 60 minus mean of 54 divided by standard deviation of 3. So you can see that this is the easiest to calculate. Write this down. Z-score is 60 minus 54 over 3. Okay, let's do it. $60, okay, minus 54. Okay, divided by 3. The number of standard deviations, 2.0, 2.0. 2.0. So I'm going to go over there and write it 2.0. And let's do the same for history. Mean class average for mean is 75, and the class standard deviation is 2, and he scored 80. So it's gonna be like 80 minus 75. 80 minus 75 over 2, which is the number of standard deviations. So we are here. Okay. Yeah. 80 minus 75. Okay. I have there here. Divided by 2. 2.5. 2.5. I'm gonna put 2.5 right here. For history, I'm gonna do what I just did. So I'm gonna write 80 minus 75 divided by 2, which is the number of standard deviation for history. So after that, what I got is 2.5 approximately. Okay. Now for biology, can do that one here. Biology, ZB Z equals gonna be biology is, yeah, he scored 65. So 65 minus 75 minus 75 divided by 2 again. That 65 minus 75 or 2. Yeah. You got it? Excuse me. 65 minus 75 divided by 2. -5. -5. So when it's negative, that means it's below average. When it's positive, it's above average. Or it's equal to the average. -5.0. So for the mass, the score is 2.0. That means let's interpret this. The student I have it here. Actually, I wrote it down already. The student score is mass is 2 standard deviation above the mean. 2 standard deviation above the mean. For history, he scored 2.5. So the score is 2.5 standard deviation above because it's positive. And her score in biology is -5.0. That means his score is 5.0, 5.0 standard deviations below the mean. So the student's score in history is 2.5, which is above average. And that is the what they ask us here. They say, on what test did he perform better? That would be on history. Okay. Okay. So the student's history is 2.5 standard deviation above the mean. So now he's performed better in history. Okay. Now, any question on this? Any question? Okay. All right. Since there's no question, we can just do the other measure of variation, which you can try this one as a practice at home. Then look at the other one. We have the percentiles. I've already mentioned that the percentile divide a distribution into 100 equal parts. So how do you calculate percentile? There are 2 formulas normally used. First of all, if you're asked to locate the percentile, you use this formula here. If you have to calculate the percentile, you use this one here. So let's do the first one. It says a teacher gives a 20-point test to 10 students. The scores are shown here. You can see the score right here. 18/20, 15/20, 12/20, 6/20, and so on. So find the percentile rank of the score of 12. B, find the percentile rank of the score of 6. C, find the value that corresponds to 25th percentile. That is, locate the 25th percentile from the list. Okay. D, find the value that corresponds to the 60th percentile. So let us start with the first one. It says find the percentile rank on the score of 12. The first thing you do is to put this in order from the smallest to largest. So I did it here. And let's find it. So once you have that, you can be able to calculate the percentile. Okay. How many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 students. Okay. Because it says it's a give 20 points there to 10 students. Okay, good. So I'm using this formula here because say find the percentile rank of the score of 12. Okay. So there are 10 of them. So N is 10. X is 12. Score of 12. Well, this one, S will now represent, I'll call it the number of items that are below, because say that N is 10, but I'm looking for the score of 12. See, it's already arranged in order. 12 right here. Now, S is how many values that are below that. That's below 12. S is 12. 12, as a matter of fact, S is 12, but my mistake. S is 12. Number of values below 12. This is 12 right here. How many? 1, 2, 3, 4, 5, 6. 6 numbers are below 12. So the percentile rank become, see the formula here, number of values below X plus 0.5. This is just part of the formula, 0.5, divided by total number of values times 100. We have this 0.5, because you are moving from, I'll say discrete to continuous. So let me put that way. So this is a correction factor. We should correct it. I'll call it continuity, some kind of continuity correction factor. Now we have 6 numbers. So plus, I'll put it in the parentheses, plus 0.5. Okay. Divided by how many number of values? Total number of values. There are 10 of them times 100. Okay, that'll give us the percentile. Let me write this down. I mean the percentile rank. So I got 6 plus 0.5 over 10 times 100. So let's do it calculator. We have 6 plus 0.5. Okay, divided by 10 times 100. 65. 65. 65. So that the percentile is the 65th percentile. So the student whose score is 12, or who scored 12, I don't here. The score of 12 falls in the 65th percentile, and the student with the score of 12 performed better than 65% of the students who took the test, of all the students who took the test. Any question on this? Yeah? No question. Okay, good. Excellent. Now, the second question says, as part B said, find the percentile rank of the score of 6. So if you come here, again, the other data will be in order from smallest to largest. S is 6. So the number of values below 6. You look at this, how many values below 6? 6 is 6 right here. How many values are less than that? 1, 2, 3. So the percentile rank become 3 plus 0.5 divided by 10, because there are 10 of them, times hundreds. So I can just go there and change the 6 to 3. It will give me the answer right away. And this 6 to 3. 3, 35, 35, 35. 35. So that the score of 6 fall on the 35th percentile, Okay, equals 35. 35th percentile. So the score of C is falls in the 35th percentile, which means that any student with that score perform better than 35% of all the students who took the test. So our next is they want us to uh find the value corresponding to the 25th percentile. That is another one asking you to locate the 25th percentile class. To locate the 25th percentile from the list. So again, this is the opposite of what we have been doing. So how to get that is to first thing is to put them in order, first of all. Okay? In order. This is where we apply this formula. Percentile of interest is n times p over 100. In this case, we're looking for the 25th percentile, so we're going to be using the p25. And n, there are 10 of them. So here n equals 10. N equals 10. Equals 10. N equals 10. Okay? P25. Yes, P is become 25. Because that's 25%. It said to find the 25th percentile, so that P is 25. Now we can now calculate it using this formula. P25 um I'll put small p here. P equals 25. Sorry, mistake. So that's the percentile of interest P25 now becomes n times P over 100. That means 10 times 25 divided by 100. So I can get it from the calculator. We got 10 times 10. Put it right here. I can just put it. Okay. Now put parenthesis. 10 times 25 over 100. That is 2.5. Whenever it has a decimal, run to the next whole number. Or even if it's 2.1, just go to the next whole number. So you have 2.5, which is the third number. So I'm going to put it right there. Third number. Get 2.5, which is the third number. And the third number from the list, see, 1, 2 is 5. So this means that the score of 5 corresponds to the 25th percentile. Does anybody have a question on this? Any question? Okay. There's no question. Okay, good. Excellent. Now, let's answer the last question in that section, which is to find the value that corresponds to the 60th percentile. So our P this time is 60. So P is 60 this time. P is 60. Okay. We have this already. N is still 10. P is 60. So you're gonna have P60 that becomes as a percentile, locating the 60th percentile. We're gonna have equals n times p over 100. That means 10 times 60 per 100. So when I put it right there, 10 times 60. Can just change it to 60. 6. So it doesn't have a decimal point. So that means if it doesn't have a decimal point, it cannot go to the next number. What you're going to do is do that number plus the next number divided by 2. So this means that since our answer is 6, it means the 6th number plus the 7th number divided by 2. So we go over there and put the 6th number plus the seventh number divided by 2. We look at the list, and let me show you to make the list bigger because it's too small. So 1, 2, 3, 4, 5, 6 number is 10. Plus the seventh number is 12. You can see right here, 12 divided by 2. 10 plus 12 is 22. 22 divided by 2 is 11. So that means the score 11 corresponds to the 60th percentile. Now, any question before we leave? Hello, scholars. Can you hear me? Hello? Let's put it this way. Mr. Rex, are you there? The Rex?
Yes.
Good, good.
I'm sorry, sir. Did you call my name?
Any questions? Any question for what we did so far?
No.
Okay. Now, we're rounding up. So next week, we begin from computing the quartiles. Now, what you're gonna do tonight is to do your classwork. Watch the video. This is not part of what we did covered now. So that's why I put a video. I want to watch the video. It's a different topic. Follow the direction to complete the classwork. It's not among the things we covered now. So this one is a self-practice. I want to see how you can, if you're able to complete this by watching this video. Next week, meanwhile, continue with your other homework, and I will see you guys next week. Okay? All right. You guys have a nice evening, and I'll see you next week.